Going to discuss a question part to given node. So sometimes the question is like part to the leaf, but if I am teaching you part to given node, so it will cover that part to given leaf also, right? So I will be solving this question, leaf or whatever. This question is a superset of every other similar question. So I found this question on interview bit, so you can also solve that question there. The rating of this question in there was easy. So basically what we need to do here, you must have got the idea. 2 3 4 5. Okay, connect it like this. Connect. So if someone asks me that give me the path of going from the root to fifth node, so what I will do, I will say keep on going here, pre-order visit 1. Okay, yep, I got 5. I got 5, right? So do I need to check again and go from here to here? No, right? If I already got 5, so what I will do, I will say that immediately as soon as you get 5, immediately go back to the parent node. The parent node will say immediately go back here, and this one will not go here and check for the right subtree. It will immediately say yes, I got the path, and the path will be returned. You got it? So as soon as you encounter that node, immediately keep on telling the parent node that, oh, I got the path, so that node will get added. So there are two ways to solve this question. Basically there is only one way. I'm just storing in my answer vector in two different ways, but the intuition is the same. I will discuss both of the solution in this video only. So what I have done here, I have I have done a pre-order traversal. Okay. Why I have not used level order traversal? Because I want a direct path, right? I want to go back. So since it was something like depth, so I used level order traversal. Oh, sorry, pre-order traversal. You can use any other type of traversal also in order, but I will use pre-order traversal. So what I am doing is uh, I am keeping I am calling the pre-order traversal. I am calling the pre-order traversal. Here's a root. Here's the key. What I need to find means the path, the node with this value equivalent to key, and the path is the vector array which I need to return as answer. So in my in order is simple. If nothing is there, so return false. And when you need to return true, you need to return true when you got the node. I got the node, yes, so I will include that node and I will say true. So that node which is basically key will be included, and I will say return true. So if I had called it from the left subtree, so this value will be true, right? This complete value will be true. So these two statements will also get executed. What are these two statements? These two statements are include this also, means which called this key node, the node which had value equivalent to key, include that node also. Parent, should I write parent 1? So include that node also and return true, because I don't need to check for the left, for the right subtree, since I already got my answer. So I will say that, okay, return. So for example, if you had traveled for the left subtree and you didn't get your answer in the left subtree, then you would have got it from the right subtree, and then you will check that, okay, this statement is correct, so include this node, return true again. If you don't encounter any that key in the left subtree or in the right subtree, in that case return false. So basically, your main focus is on true, and other than that everywhere you need to write false. So you then get into your tree. uh, so it's like root here, and p2, p1, p2, p1 key. Here is whatever. So you are storing the nodes in this fashion, right? In this fashion, this first key, then this, then this, then this. So what I need to do, I need to reverse this, since I want root from root to node, from root to node, path from root to node. So I have written this reverse. And if I don't want this extra thing to do, because this is also consuming some space complexity, right? Reversing, if you want to reverse a sorted vector, so if you want to reverse something, so what you will do, how much time will it take? N by 2 times, which is almost n, right? So extra n I don't want. So what I will do, the intuition will be same, but how I am adding is something different. So first I will say that okay, I will keep on adding, so first I, as soon as I encounter root, I will say key at the root. If I go to parent, if I go to left side, I will say okay, include this. Then I will go to the left subtree. I will say okay, include this. And if there is nothing here and this is not also my answer, so I will say okay, now when you are going, so remove. Here I will say add this to your answer. Here I will say remove this to your answer. Then again it will go to the left subtree, right subtree. So it will again say add, and it will check for the left children, right children. Then it will say remove. So and here if you didn't find anything, so it will also say remove. Then you will go to the right subtree of this root, and you will say okay, here you add it and here you got the answer. Okay, here you got the answer, so you will say that don't remove this, you directly go up. Yeah, this node will check that okay, is it true? Is it true? Yes. If it is true, then simply return true. Simply return true. Don't remove. Don't remove. Otherwise, what you will be doing? Remove. Here you will be adding, here you will be removing. But you will say that don't execute that remove statement. Just go back. Just go back. So it will go back. And root will also not execute its remove statement, and it will uh, and before this statements, this remove statement gets executed, I will be saying I got true from here. So root, you also return true, so you will return true, and this statement will again not get executed. So let us now check the code. You got the intuition, right? So when you encounter this node, so you will say okay, include it to your answer, and say true, I got the node. If you And before calling for the left subtree, I will say that okay, include it. And if the path, if that path did not have any, if that part did not have the key which we were trying to find out, so this truth statement will not get executed, but this pop back statement will get executed, and this node will get removed here. Okay, similarly this will be happening. uh, you will be adding the node here. If you get your answer in your right subtree, so you will say that return true, and this statement will not get executed, this pop back statement will not get executed. And And so this node will not be removed. This node will not be removed, not be popped back, and this will be writing true here. So basically we will be going out directly, and we will not be removing anything. So try to do this same thing in on the pen and paper, using pen and paper. And I think uh, the solution was very simple of this video, of this question. So if you have enjoyed the video, so don't forget to like the video, and I will see you in the next one.